All right, so section 7.2, and we're still looking at the disk method because that's pretty much all that's here. And so what we want to do here is think about rotations, okay? Because that's how many of these problems are going to be given to us, but it's also the case of thinking about an object and how an object is made. And so if I take something like y equal x squared, and now I say, well, what I want to do is rotate it around the x-axis. Then we're going to, when it rotates around, we're going to get the mirror image down here, but it's rotating all the way around, and so it ends up making sort of this cone type of solid, and the bottom would be this circle here. That's a circle in perspective, and so if we want to model this as disks, okay, we would slice it along the x-axis, and we would take any given slice here and ask, oh, well, what's the radius of the disk there, and we're going to get that from thinking about the rotation around the x-axis. And as we look at that, r in this case is just our x squared. And so to make our disk, or disk, we remember it's just our pi r squared, I'll use lowercase h. That's our volume of any given disk that we have. And again, typically that height is just our delta x. And so here r is x squared. So actually we get pi x squared squared and times delta x. And we didn't give any limits on this. Suppose I want to go from 0 to 1. In this case, then, this if I'm rotating around the x-axis, I end up making slices perpendicular to the x-axis, and so I'm sort of slicing up the x-axis as I go, and so we get our integral from 0 to 1 of pi x to the 4th dx. And so this is pi x to the 5th over 5 from 0 to 1. And so we just get pi over 5 for our volume. Okay, so that's a rotation around the x-axis, but I could have taken that same curve and rotated it around the y-axis. And so as I do that, then you see I make my arrows here. As I do that, then we get a slightly different looking figure. It's still sort of a cone, but up here above, that was a concave cone, and this one is a convex cone. And or do I have that? I'll have to get back to you on that. But at any rate, actually, it is a good question. Like I say, I'll have to get back to you on the convex concave of the cones. And so we want to make this cone, and in order to get disks this time, we would have to slice up the y-axis. And so no big deal. Again, our disk, do it with a C because I'm pretentious. As I make that disk here, right, we still need a pi r squared h to get our volume of a given disk. Well, now because we're rotating around the y-axis, we're going to make slices perpendicular to the y-axis to make our disks. And so now that h is a delta y, and the height, or the radius here, well, I have to think about that, right? That we had the function, remember, y equal x squared. Well, but for a given y, then how far is that? Oh, well, that's do an inverse sort of thing, right? And we get x is equal to the square root of y. And so in this case, for this thing, and remember, we were at 1 here, but that means we're also at 1 there. And so we're going to slice up the y-axis, and we're going to have pi square root of y squared when we slice that thing up, and for a given disk. And so that means we will want the integral from 0 to 1 of pi y dy, and that gives us pi y squared over 2, and that's from 0 to 1. And so we get, in this case, pi over 2. Okay, so we had these two different cones. The first cone, kind of had a shape like that and had had a volume of pi over 5. And then the second cone had a shape more like that, and we can put some roundedness to it. And that cone had a volume of pi over 2, and given they had the same base, it seems very reasonable, right, that this cone would have the bigger volume and this cone would have the smaller volume. Okay, so that's the idea of these rotations. We just have to think about, they'll just tell us rotate around something. These were both axes, and we'll also look at what we do when we rotate around a line that's not an axis, and various other rotations as far as making other figures. And so though that's our first dive into the rotation aspect of building these disk models to find volume.